Welcome to all. This is Srinivasan, Assistant Professor, Department of Mathematics, Sri Sairam College of Engineering. Today we will discuss the topic is Fourier transform. It's module 3. In this Fourier transform, it contains two parts. One is Fourier transform, another one is inverse Fourier transform. We will discuss one by one. First, we will discuss what is meant by Fourier transform. So a Fourier transform in the mathematical way is nothing. We can transform time t to the frequency of s. So t2 we can convert to s, time to frequency. Okay, we can transform to time to frequency. That is the meaning of transform, Fourier transform. So now we will discuss formula for the Fourier transform and inverse Fourier transform. So the first formula is the Fourier transform. What is Fourier transform formula? Capital F of S equal to capital F of x. The meaning is Fourier transform of f of x. That is equal to 1 divided by root 2 pi interval minus infinity to plus infinity f of x e power isx into dx. And the next one, inverse Fourier transform. So the inverse Fourier transform is f of x equal to 1 divided by root 2 pi interval minus infinity to plus infinity capital F of s into e power minus isx into ds. So these two formulas are very important to solve the problem for the Fourier transform. This two formula is called Fourier transform pair formula. Okay. Now we will discuss the problems, how to solve the problems. So first problem, find the Fourier transform of f of x. The function is a minus modulus x. When it is a minus modulus x, if modulus x less than or equal to a, and another function is 0 when it is modulus x greater than a. Hence deduce that the deduction is interval 0 to infinity sine t divided by t the whole square into dt equal to pi by 2. Before going to solution, first we discuss the interval. See, what is the here interval? Modulus x less than or equal to a. The modulus x less than or equal to a is nothing. Interval is occupied in the minus a to plus a. Okay. The function occupied in the interval, it is minus a to plus a. So minus a to plus a, the function is a minus modulus x. Remaining all 0. So the full interval is minus infinity to plus infinity. I split three parts. One is minus infinity to minus a, another one is minus a to plus a, another one is a to infinity. So minus a to plus a, we get the function that is a minus modulus x. So remaining all the interval, the function is 0. Okay. Now find the Fourier transform. So Fourier transform formula is 1 divided by root 2 pi interval minus infinity to plus infinity f of x e power isx into dx. Now substitute the f of x value in the three interval. So this is the first interval of f of x, this is the second interval of f of x, and this is the third interval of f of x. Clearly first function is 0 and the third function is 0. So the entire term is 0 for the first and the third. We get only second term. Interval minus a to plus a minus modulus x, e power isx into dx. See here e power isx, that is e power I theta. We know e power I theta equal to cos theta plus I sin theta. Here theta equal to sx. And next I split these two terms. One is cos term, another one is sin term. So this is the cos term and this is the sin term. By integral property, if the range is full range, if the interval is full range, then the function is even, we get some value. If the range is full range, the function is odd, the value is 0. When we can check it is odd function or even function, the entire the range is full range. If the range is full range, only we can discuss the function is odd or even. Clearly cos theta is a even function and the sin theta is a odd function. So this is odd function and the range is full range, therefore the entire value is 0. Okay, clearly I explained this line. This is the odd function. So we get only one term. And this one 1 divided by root 2 pi interval minus a to plus a minus modulus x cos sx into dx. The second term is 0. Okay. Now see the interval, it's a full range. So I split it is a half range. I convert by half range. So 1 divided by root 2 pi into I multiply 2 into it will be 0 to a. It's a half range. A minus modulus x into cos sx into dx. Taking 2 outside, that is 2 divided by root 2 pi. Then here we put x. Why we here we put x? Modulus x is nothing. Modulus x equal to plus x when the range is positive, and modulus x equal to minus x when the range is negative. Clearly, see here range is positive, therefore modulus x become plus x. So a minus plus x into cos sx into dx. Now apply Bernoulli's formula. What is Bernoulli's formula? The shortcut is here I explain the shortcut. Take the first term. What is first term? A minus x, and integrate the second term. So cos sx integration is sin sx divided by s minus, change the sign. Here first we can put plus, next minus. Differentiation of first term. So a differentiation 0 minus x differentiation is 1, we get minus 1. So differentiation and integration of sine this term. So sine sx divided by s integration is minus cos xs divided by s square. Next change the symbol. Here minus, na, next one is plus. So differentiation. So differentiation is next term differentiation is 0. Hereafter every term is 0. Okay. The meaning is take the first term, integrate the second term, change the symbol. Differentiation, integration, change the symbol. Differentiation, integration up until we get 0 value. Okay. Now substitute the upper limit. What is upper limit here? A. Substitute to replace x equal to a minus a equal to 0, 0 into this term is 0. And minus into minus plus, plus into minus minus, replace x equal to a, we get cos as divided by s square. Upper limit minus lower limit. What is lower limit? 0. Replace x equal to 0. If you replace here x equal to 0, sin 0 is 0, 0 into this term is 0, and here replace 0, cos 0 is 1, we get minus 1 by s square. Multiply minus inside, we get 1 divided by s square minus cos as divided by s square. Denominator is s square is equal, so adding the numerator we get 1 minus cos as. What is 1 minus cos theta? That is 2 sin square theta by 2. 1 minus cos theta equal 2 sin square theta by 2. Here theta equal to as. So 2 sin square theta by 2, theta equal to as by 2 divided by s square. Taking 2 outside, we get 4 divided by root 2 pi, and sin square theta divided by s square, that is sin theta divided by s the whole square. Okay, this is our required f of s. Next, deduction. If you want to solve deduction, we can apply only inverse Fourier transform. So first our aim is to find Fourier transform f of s. After that, if you want to solve any deduction, we can apply only inverse Fourier transform. What is inverse Fourier transform? We know the formula 1 divided by root 2 pi integral minus into plus infinity capital F of s e power minus isx into ds. Substitute f of s value. This is f of s value. Okay, we get, see the deduction, there is no term of e power minus isx, so I want to cancel this term, and at the same, see the deduction, the denominator is mentioned t, so clearly here s equal to t, here s equal t, and x I want to choose, and I want to cancel this term. How to choose x? X equal, if you choose x equal to 0, we get e power minus 0. E power minus 0 value is 1, so automatically it will be cancelled, and s equal to t. And see the deduction, we get here sin t only. The here extra term is a and extra term is 2. I want to cancel this a and this 2. That's why I choose a equal to 2. So we have f of 0 equal to 2. So f of 0 equal to 4 divided by 2 pi integral minus into plus infinity sin 2s divided by 2 divided by s the whole square into this term is 1. So taking opposite direction, we get 1 equal to 2 by pi interval 0 to infinity sin s divided by s the whole square into ds. So this is interval 0 to infinity sin s divided by s the whole square into ds equal, taking opposite direction, we get pi by 2. So deduction is only t terms. Here the variable is s term. So I replaced s equal to t. So interval 0 to infinity sin t divided by t the whole square into dt equal to pi by 2. This is our deduction. So here we used two formulas. One is Fourier transform formula. Another one is inverse Fourier transform formula. First we have to find Fourier transform. After that, if you want to solve the deduction, we can use inverse Fourier transform formula. So this is the